It's 2 a.m., you're scrolling through your phone, and that little voice in your head whispers, I should really get my 8 hours. But here's a question that might blow your mind. What if that sacred 8-hour rule isn't actually written in stone? What if your brain has been trying to tell you something completely different all along? Let me take you on a journey into the most fascinating frontier of neuroscience, the sleeping brain. Because what we're about to discover will challenge everything you thought you knew about sleep. So where did this magical number come from anyway? Here's the thing. The 8-hour sleep recommendation isn't some divine law carved into our DNA. It's actually just a population average, kind of like saying the average shoe size is 9. But would you force everyone to wear size 9 shoes? Neuroscience tells us a completely different story. Some people carry genetic variants, like mutations in the DEC2 gene, that allow them to function perfectly on just 6 hours of sleep. These aren't sleep-deprived zombies stumbling through life. Their brains literally process sleep more efficiently. Meanwhile, others need 9 or even 10 hours to feel human again. Think about it this way. If sleep needs were truly universal, why would evolution create such diversity in our sleep patterns? The answer lies in something called chronotype variation, and it's absolutely brilliant. Let's dive into what's actually happening in your skull while you sleep, because this is where things get really wild. Your brain isn't just turned off during sleep. It's running one of the most sophisticated maintenance programs in the known universe. Every night, your brain cycles through distinct phases that serve completely different functions. During slow-wave sleep, that deep, restorative phase, your brain literally shrinks its cells to create more space between neurons. Why? To flush out toxic waste products like beta amyloid and tau proteins that accumulate during the day. This process, called glymphatic clearance, is like having a night janitor for your brain. But here's the kicker. Some people's brains are simply more efficient at this cleaning process. Their glymphatic systems work faster, their neural oscillations are more synchronized, their memory consolidation happens more rapidly. These people might genuinely need less sleep because their brains accomplish more in fewer hours. Now, before you get too excited about becoming a short sleeper, let's talk about what happens when you don't get enough quality sleep. And I'm not talking about feeling a bit tired, I'm talking about your brain literally falling apart at the cellular level. When you're sleep deprived, your prefrontal cortex, the CEO of your brain, starts shutting down. Decision-making becomes impaired, emotional regulation goes out the window, and your ability to form new memories crumbles. But the really scary part, your brain's waste disposal system essentially goes offline. Imagine your brain is a city, and every night, the garbage trucks come to clean up the metabolic waste from the day's activities. When you don't sleep enough, it's like calling off the sanitation department. Beta amyloid plaques, the same proteins found in Alzheimer's disease, start accumulating. Your neurons become inflamed. The very infrastructure of your mind begins to deteriorate. Studies using neuroimaging have shown that people who consistently get less than 7 hours of sleep have smaller hippocampal volumes, increased white matter volume, and decreased gray matter volume matter hyperintensities, basically brain damage and accelerated brain aging. We're talking about your brain literally aging faster than your chronological age. So if 8 hours isn't universal, what is the sweet spot? Neuroscience research reveals something called the U-shaped curve of sleep and mortality. Both too little sleep, under 6 hours, and too much sleep, over 9 hours, are associated with increased health risks. But here's what's fascinating. The optimal zone isn't a single number. It's a range. typically between 7 to 9 hours for adults, and it's deeply personal. Your optimal sleep duration depends on your genetics, your age, your lifestyle, your stress levels, and even your exposure to light throughout the day. The key insight from neuroscience is this: your brain will tell you what it needs if you know how to listen. Quality sleep leaves you feeling refreshed, alert, and cognitively sharp. Poor sleep, regardless of duration, leaves you feeling groggy, irritable, and mentally foggy. Here's where the story takes an unexpected turn. Recent neuroscience research suggests that sleep quality might actually be more important than sleep quantity. You could sleep for 10 hours and still feel terrible if that sleep is fragmented, light, or doesn't include enough deep sleep stages. Sleep regularity, going to bed and waking up at consistent times, appears to influence neurological function even more than total sleep duration. Why? Because your brain operates on circadian rhythms that are more ancient and fundamental than you might imagine. These internal clocks coordinate everything from hormone release to memory consolidation to cellular repair. When you mess with these rhythms by sleeping at wildly different times, you're essentially giving your brain jet lag every single day. The neural networks that should be communicating seamlessly become desynchronized, like an orchestra where the musicians are all playing different songs. Let's get personal for a moment. What determines your unique sleep needs? It turns out your brain is like a fingerprint, absolutely unique in its sleep requirements. Genetic variants in circadian rhythm genes like PER3 and CLOCK influence whether you're naturally a morning person or a night owl. Variations in adenosine receptor genes affect how quickly sleepiness builds up during the day. Some people have naturally higher amounts of slow-wave sleep, making their sleep more efficient. Your brain's white matter integrity, essentially the quality of the connections between different brain regions, predicts how resilient you are to sleep deprivation. People with better connected brains can often function better on less sleep, while others need more sleep to maintain optimal cognitive performance. Age plays a massive role too. As we get older, our sleep architecture changes dramatically. Older adults typically need less sleep, not because they require less rest, but because their aging brains become less capable of generating deep, restorative sleep. One of the most mind-blowing discoveries in sleep neuroscience is how memories are processed during sleep. This isn't just about feeling rested. It's about literally rewiring your brain every single night. During REM sleep, your brain reactivates the neural patterns that were formed during learning. It's like hitting the replay button on your day's experiences. But with a twist, your brain is also deciding which memories to keep, which to discard, and how to integrate new information with existing knowledge. Slow-wave sleep takes this process even further. The characteristic slow oscillations of deep sleep coordinate the transfer of memories from the hippocampus, your brain's temporary storage system, to the neocortex for long-term storage. Without adequate deep sleep, this memory consolidation process breaks down. But here's the personalized aspect. Some people naturally generate more robust sleep oscillations, making their memory consolidation more efficient. Others might need longer periods of sleep to achieve the same level of memory processing. Here's a reality check that might surprise you. The idea of sleeping for 8 continuous hours is actually a relatively recent invention in human history. Before the Industrial Revolution and widespread artificial lighting, many cultures practiced what's called biphasic or segmented sleep. People would have a first sleep after sunset, wake up for a few hours during the night for quiet activities, prayer, or conversation, then have a second sleep until dawn. Historical records from Europe, Africa, Asia, and the Americas all document these patterns. This suggests that the human brain might actually be naturally adapted for more flexible sleep patterns than our modern sleep 8 hours straight approach. Some people today still naturally gravitate towards segmented sleep and feel more refreshed with this pattern than with continuous sleep. So where does this leave us? The cutting edge of sleep neuroscience is moving toward personalized sleep medicine. Instead of generic recommendations, we're developing AI-powered systems that can analyze your individual sleep patterns, genetic profiles, and lifestyle factors to determine your optimal sleep duration and timing. Wearable EEG devices can now monitor your sleep stages at home, tracking the quality and efficiency of your sleep cycles. Machine learning algorithms can identify patterns in your sleep data that predict cognitive performance, mood, and health outcomes. The future might involve adaptive sleep schedules that change based on your circadian rhythms, stress levels, and cognitive demands. Imagine a system that knows you need an extra hour of sleep before an important presentation, or that can optimize your sleep timing for peak athletic performance. So, do you really need 8 hours of sleep every night? Neuroscience gives us a nuanced answer. Maybe, but probably not exactly 8 hours, and definitely not if it's poor quality sleep. Your brain is constantly sending you signals about what it needs. The key is learning to interpret these signals correctly. Good sleep should leave you feeling refreshed and mentally sharp. If you're consistently waking up groggy despite getting 8 hours, the problem isn't necessarily the duration. It might be the quality, timing, or regularity of your sleep. The most important factors, according to neuroscience research, are consistency in your sleep-wake schedule, adequate time in deep sleep stages, proper circadian rhythm alignment, individual optimization based on your unique biology. Rather than obsessing over hitting exactly 8 hours, focus on creating conditions for high-quality, restorative sleep. Pay attention to how different sleep durations affect your cognitive performance, mood, and overall well-being. Your sleep needs are as individual as your brain itself. Some people are naturally efficient sleepers who can thrive for 7 hours, while others need 9 hours to function optimally. The key is finding your personal sweet spot through careful observation and, ideally, objective measurement. What matters most isn't conforming to a universal standard, but optimizing your sleep for your unique neurobiological needs. Your brain has been trying to tell you what it needs all along. Maybe it's time we started listening. The 8-hour rule isn't wrong, but it's incomplete. The real rule is this: give your brain what it needs to do its incredible work of memory consolidation, waste clearance, and neural restoration. For some, that's 7 hours. For others, it's 9. The magic isn't in the number. It's in the quality, timing, and regularity of your sleep. Your brain is the most sophisticated machine in the known universe. Isn't it worth learning its unique operating instructions